Hi students. Today's topic is wheatstone bridge. Wheatstone bridge is totally based on the principle of KVL and KCL. Why wheatstone bridge is used? Wheatstone bridge is basically used to measure, to calculate the unknown resistance connected in a circuit. So how it is work? What is the basic principle behind it? We will discuss about the principle of wheatstone bridge. If you want to find out the principle of wheatstone bridge, you exactly want to understand the principle of wheatstone bridge. First of all, you have appropriate knowledge about KVL and KCL. What is KVL? KVL stands for Kirchhoff's voltage law and KCL stands for Kirchhoff's current law. So firstly, a brief introduction about KVL and KCL. Then after, we will discuss the basic principle related to wheatstone bridge. So first, we will start KVL and KCL. So what is KCL basically? Kirchhoff's current law. So Kirchhoff's current law, K stands for Kirchhoff, C stands for current, and L law, and it state that basically if there are, let's suppose current I1 and current I2 meeting at the junction O, and I1 and I2 are incoming currents and result is I3, that is outgoing current. So according to Kirchhoff's current law, the sum of incoming current will be equals to sum of outgoing current. But here you can say that there is only one current. So you can consider another wire having current I4. Okay. So at this junction O, you can apply KCL. So according to KCL, the sum of incoming current, that is I1 plus I2, is equals to sum of outgoing current, which is I3 plus I4. So at this junction O, you can summarize the equation I1 plus I2 minus I3 minus I4 is equals to 0. So mathematically, smartly you can write it down, sigma I is equals to 0, where I stands initiated from 1 to n if there are n number of current at the junction O. So this is basically the basic principle of KCL. Now we will discuss a short description about KVL. What is KVL? KVL stands for Kirchhoff's voltage law. KVL stands for Kirchhoff's voltage law. So we will consider a circuit, that is circuit ABCD, in which there is a resistance capital R, and you can nominate the point A, point B, point C, and point D, which are connected with the battery E. So there are basically two elements. This is active element which is a basically energy source, and this is passive element. This is basically consuming the energy. The total drop generated by the energy source E will be dropped at the resistance R. If you consider the current I from this battery, the voltage drop along the resistance will be IR, and this drop can be considered as a negative drop. So there are some rules and regulations regarding KVL. What are basically these rules and regulations? We will firstly consider, then we will take an example which will clear you how KVL is applied in a circuit. So we are considering the basic laws related to KVL. Basic instruction, basically you can say that, related to KVL. The basic instruction are: the drop will be considered as a negative. That means voltage drop IR will be negative if you are going along the loop. What is loop? Loop, if you are considering a loop here, A, B, C, D, A, B, C, D, A. This is a closed path starting from point A, B, C, D, A. This is basically a loop because this is a closed path. The current is flowing in a closed path, and the potential drop will be considered as a negative if you are going along the considered loop ABCD, and the direction of current is also along ABCD. The direction of current and the direction of loop is same, then you can say that the drop, which is potential drop, will be considered as a negative, else it will be considered as a positive element. Next rule is, you will write the second terminal of the EMF. What is second terminal? If you are moving from B, C, D, A, so you will first find the negative terminal, then you will approach to the positive terminal of the battery. And this positive terminal of the battery is the second terminal. So while writing the sign of EMF, you will write the sign of second terminal. So in this figure, what is the sign of second terminal? You can say that it is a negative and it's a positive. So positive will be the sign of EMF if you are moving along the loop ABCD. The direction of loop is A, B, C, D, A. It's the direction of loop. Then you will write the sign of E is positive, that is second terminal. Second terminal of cell. These are the basic instructions regarding the KVL. So considering these instructions, you can write any equation which are complex, it may be simple, depending on the situation of a circuit. You can write down the equation using KCL and KVL. Now, I just want to apply these laws in wheatstone bridge. What is wheatstone bridge? Wheatstone bridge is a basically very important instrument in physics. You can find it in physics lab. We are having this as a physics lab instrument. And what is the purpose using wheatstone bridge? Why we use wheatstone bridge? The wheatstone bridge is basically used for measuring unknown resistance in the circuit. If there is any unknown resistance in the circuit, you will calculate the value of unknown resistance applying the concept of wheatstone. So now we will discuss how wheatstone circuit is made and what are the outcomes of that wheatstone bridge. So student, you can write it down as a note. You will make a note because it will help you while calculating the numerical problem also. So what we are going to discuss? We are going to discuss wheatstone bridge. We are going to discuss wheatstone bridge. So I think you have learned properly what are KVL and KCL. Now you will be able to understand the concept of wheatstone bridge. So we will take a circuit of wheatstone bridge. It's a very basic circuit, but what if the circuit is given? We will consider it. So what is circuit? Wheatstone bridge. It's a basic circuit. If there is a square-shaped circuit and there are resistance in respective arms of the circuit, there are resistance in respective arm of the circuit. Okay, so here is a junction. So in the question, the junction is written as junction A, and here is another junction which is written as a B. So you can consider it A, B, C, D, whatever you can want to take the points, you can consider as per your own convenience. There is no hard and fast rule. Basically, this is the point A and this is the point B. You can search it out also. There is an electrical source E. Sometimes there is a rheostat. You know what is a rheostat? Rheostat is basically a circuit which provides variable resistance. But here we are using only electrical circuit EMF as a voltage source. So if there is a current I which will be further divided in I1 and I2, let there are 2 points C and D which are connected with a galvanometer G. Here is a key may be represented by K1, K2, as we will consider this key is a K1 and the key at this is K2. So when K1 and K2 are at close situation, The current I will be divided in two parts, I1 and I2. The current I will be divided by two parts, I1 and I2. At this junction A, you can apply what? You can apply KCL. If there is any need, you can apply KCL. What is KCL? Kirchhoff's current law. So I is equals to I1 plus I2, because I1 is an incoming current and I2 and I1 are outputs and I is a basically input current. The input current is equals to outgoing current. Now this is input and this is output. Okay. So here you can consider a loop A, C, D, A, another loop C, B, D, C. So if there is no deflection in the current, what is the principle behind wheatstone bridge? If there is no deflection between the needle of the galvanometer, there will be the condition if and only if when the potential of point C and potential of point B, D is same. It is possible only when the potential of point C and potential of point D is same, because at the same potential there will be no potential difference between C and D, and hence there will be no current in galvanometer. Okay, so we will consider a loop. First loop is A C D A. First loop is A C D A. Okay, so it's a complete loop. So you can write down KVL here. So KVL. Apply the KVL as we are moving along the circuit, and the current is in the same direction. The voltage drop will be considered as a negative, and you can write the resistance of P, Q, R and S. The resistance of the arm will be considered as P, Q, R, S. So what will be the drop, potential drop along AC? Minus I1P. So there is no resistance in between. Then you will come along DA. The direction of loop and direction of current is opposite. Hence, you will write down the drop here as a positive IR. Positive IR. यहाँ पे complete करिए. At point A, you have just completed the whole loop. So you can write down I1P plus I2R, that is equals to 0. It's a basically concept of KVL that within the loop the total drop is 0. Sum of all the drop, where it's a generating source or it's a passive element, the total drop or the summation of total potential drop along the circuit will be a 0. So in the loop number 1, you can write the equation like this. Now we are considering the loop 2. The direction of the loop is as shown in the figure. You can reverse the direction of the loop and write the equation as a practice. So we are considering the loop number 2. Loop 2 is C, B, D, C. This is the loop. Apply the KCL. No, apply the KVL. There is no need of applying KCL. So apply the KVL, Kirchhoff's voltage law, along the loop. So we are starting from the point C. The drop is, if there is no passes of current in the arm CD, the total current I1 will pass through the resistance Q and total current I2 will pass through the resistance S, as there is no leakage of current from point C and D. As we have already said, the voltage of point C and D are equal. Okay. So what is the equation of loop number 2? We are moving along the direction of the loop and the current direction is same as the direction of loop, and drop will be minus I1Q. Okay. So here is the I2 direction and loop direction is opposite. So plus I2S. There is a no drop and we have reached to the point C. The loop has been completed and the equation will be like this. This is the equation number 2. Summarize these equations and find out the result. From the equation number A, I think it's visible to all. Equation number A, and this is equation number B. I1P is equals to I2R. Check it. I2Q is equals to I2S. So just divide these equations. You will find out. Divide these equations. You will find out the equation P upon Q is equals to R upon S. If there are 3 unknowns resistance in the circuit, the fourth one will be find out using this balance equation. P upon Q is equals to R upon S. And another result you can find out, P upon R is equals to Q upon S. So this is the basically concept of wheatstone bridge. Okay. So I think you have learned and enjoyed the topic, and next day we will come with another topic.